In this video, I'm going to introduce the idea of a set and talk about set notation. So let's first talk about what a set is. So a set is a well-defined collection of objects. Okay, and let's break that down a little bit more. So what does well-defined mean? Well-defined just means that the definition is not subjective, meaning you don't have to use your opinion to figure out what's in the set. And what do I mean by objects? Well, that really it could mean a lot of things. So objects could be letters, numbers, a list of names, a list of, people, types of animals. Really, there's no limit or restriction to what objects could be. And so let me give you a couple of examples so this can make a little bit more sense. And when I give you these examples, I'm going to name my sets with a capital letter, because that's customary when we name sets. So for example, let's say I have a set where I list out all of the letters in the alphabet. So I could call this set capital A. I could call it anything I wanted to as long as I use a capital letter. So I'm going to just pick capital A, and I'm going to use curly brackets and list out my set in what's called roster notation. I'll talk about this a little bit more later on. But I'm just going to list out all of the letters in the alphabet. So A, B, C, D. And if a set has a lot of elements, oftentimes what we can do is use the three dots, which is called an ellipsis, so that we don't have to list everything out and at least list one or two elements at the end. So this would be how I could write out the set of letters in the alphabet. Another example might be to have a set, maybe I call it E, where I list out even numbers between 2 and 8. So I'm not using my opinion there. By definition, if I told anybody, list out the set of numbers, even numbers between, or from 2 to 8, they would start at 2, 4, 6, and stop at 8. Okay, one more, maybe I have the set S and I list out all of the states in the US. And so I would just list out Alabama and Alaska. And I'm going to use a ... so I don't have to write them all out. I could end with Wyoming. Okay, and so now that we know what a set is, let's talk about how we can refer to objects that are in a set. And so if an object is in a set, we can call it an element. So for example, B is an element of the set A, or 4 is an element of the set of E that I defined, even numbers from 2 to 8. And so we have some notation to use, which is handy, so we don't have to write out that whole sentence like 4 is an element of, that set. And it's this curved E right here, and it means is an element of. So for example, if you wrote this out, this says in words, 2 is an element of the set 2, 3, 5, 7, and 11. We could also just name the set and call it set A. So let's say we made set A be the set 2, 3, 5, 7, and 11. Pretend like the setup here isn't called A for a minute. So if I said 2 and then use that symbol A, this just means 2 is an element of A, and that way I don't have to write out the whole set, all of the elements in the set. And then if we want to talk about an element not being in a set, we can use this symbol, which means is not an element of. And so for example, this right here means 4 is not an element of the set 2, 3, 5, 7, or 11, or we could just say 4 is not an element of A. And so let's look at an example where we talk a little bit more about what it means for a set to be well defined or not. So in these, I want you to ask yourself, do I have to use my opinion to come up with this list, this set, all of the elements in the set? And if you do, it's not well defined. If you know exactly what should go in there, then we say it's well defined. And so for A, the set of people in this classroom under the age 25 right now. So I want you to imagine that you know everyone's age, or you could go around and ask everyone their age in your class. And so assuming that you knew everyone's age, that's a well-defined set. I'm going to say that's yes, because everybody has an age, and you could go through and just make a list of the people that are under the age of 25. Whereas with B, the set of tall people in the classroom, that's a little bit harder to make that list because you have to use your opinion. So since you're using an opinion, We say that's not well defined because different people might come up with different lists of tall people depending on what they consider tall. And then let's look at example 2. So write the set of months of the year that begin with the letter J. So that's well defined. I know what months start with the letter J. So I just list out January, and we have June, we have July, and it doesn't matter what order I write these in. I could have written it, in a different order, and that would have been okay too. If I wanted to, it doesn't tell me, but I could even set this list equal to a capital letter so I could name this set. Maybe I call this this set J. And so then the follow-up question asks, is May an element of the set? And so I would say no. May is not an element of set J because it's just not in that list. It's a month that doesn't start with the letter J. So now let's look at the different methods that we can use to designate a set, or like write a set, describe it. So the first is roster method, and that's the method I've been using. So the examples that I used at the beginning, where I just listed out the elements with curly brackets, that's roster method. Description is just a short statement, so that's in words describing a set. And then the third, and this is usually the hardest for people, is set builder notation. The nice thing about set builder notation though is that it's always set up the same way, and once you get used to how this setup works, I promise it'll get easier as you go on. And so basically how it works is you will name the set with a capital letter. We've talked about that before, and you're going to use curly brackets to start and end the set, and then you always put an X and a vertical line. And you can read this vertical line. You say all values of X such that, and then you list out any conditions, like the set S is the set of all X such that, maybe X is a number between 2 and 5 or something. So the description would describe what X is. So let's do some examples so that we can kind of put this all together and make some more sense of it. So we are going to focus just right now in this example on sets N, I, and E, and these are special sets that mean a very specific thing. So if you see a capital N, this means the set of natural numbers, and natural numbers are counting numbers. So it's very similar to whole numbers, but whole numbers include the number 0, whereas natural numbers do not. So natural numbers are like 1, 2, 3, 4, 5, and so on. It goes forever and ever in the direction to the right, the positive numbers. And so a description for this set would just be the set of natural numbers. And then for set builder notation, I'm going to start by drawing a curly bracket, and then an X, and then a vertical line. And so I say this out loud as all values of X such that, and then I just describe either in words or shorthand notation if there is some notation. So I could just write out the set of natural numbers. Since I know that the letter N, capital N, represents the set of natural numbers, I can just say X is an element of N, and this means all values of X such that X is, or is an element of, the natural numbers, so the list of all natural numbers. So let's look at I. So set I is the set of integers, and those are negative and positive whole numbers, and so that does include 0. And so integers would be numbers like, I'm going to start with a ... because the set goes on forever in the left and right direction, in the negative and positive direction. So it'd be numbers like -3, -2, -1, 0, 1, 2, 3, and I'll put a ... going this way too. So it keeps on going. So notice it includes 0 and then the positive and negative counting numbers. And then the way I could describe this in words would just be the set of integer numbers. Okay, and then this is what the set builder notation looks like. It's very similar to the set builder notation for natural numbers. So all values of X such that X is an integer is basically what this says. And then last, we're going to look at E. And so E stands for the set of even natural numbers. And so we can just look at the natural numbers up here and pick out the even ones. So the first even natural number would be 2, and then 4, and then 6. And this set goes on forever. So I'm just going to use a dot, 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 and then a curly bracket. And then we've already got the description, and then the set builder notation would be curly bracket, x, vertical line, so all values of x such that x is an element of E, or that X is, we're listing out all of the even natural numbers is what that says. Okay, so let's do an example where we put all these together. So designate the set S with the elements with these numbers using roster notation. Okay, so I would use curly brackets and I'm going to list these all out. So I would just list out 3200, 3201, 3202, 3203, dot, 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 all the way to 3500. Okay, and then the descriptive method. So this is the part where you have to ask yourself, well, how could I describe this in words? And the first thing that I notice is that these are numbers that could be considered natural numbers because they're counting numbers. I don't see any fractions or decimals. They're not negative. So these are natural numbers. I'm starting at 3200 and I'm ending at 3500. So I could write just that. So I could just write the set of natural numbers starting at 3200 and ending at 3500. And it's really important that I put natural numbers because if I did not, if I just said the set of numbers starting at 3200 and ending at 3500, I wouldn't know that I should just use the natural numbers. I might think that, I could use decimals or maybe I could use fractions. So maybe I start with 3200 and maybe I go to, 3200 0.5 and then 3201 and then 3201.5. There's a lot of ways to count from one number to the next using decimals. So you want to make sure to explicitly say that we're just looking at those natural numbers, or these are also whole numbers too. So just those counting numbers. And then lastly, let's look at set builder notation. So I'm going to use a curly bracket and an X and a vertical line, and I'm going to use notation for the natural number part. So I'm just going to say X is an element of N because it's a natural number. But then I also have to be more specific. I'm just going to say and X is between. So the way that I write that is I use greater than and less than symbols. So I can write it like this, and this means X is greater than or equal to, because we always read where we're talking from. So if I'm talking about X, the greater than part is facing the X. So X is greater than or equal to 3200 and less than or equal to 3500. We could have also said, I just want to point this out, I'm just going to say or here. If you would have said all of this beginning stuff, but then maybe didn't want to use greater than or equal to signs, maybe you wanted to use just the less than sign, we could say X has to be greater, so that means not including 31.99 and less than 35.01, because if we're not including these values, that means the X would have to start at 3200 and it would need to end at 3500. So there's more than one way sometimes to describe a set using set builder notation.